Now we turn to the lecture theatre in Decatur, Georgia, with the atomic mass of the elements on the periodic bed of electronic elements. We have reached up to sodium, which has atomic number 11, and by the rule we would say we will double and get 22 here. But sometimes the rule is off, but that's just for general estimation to get the atomic mass. But in actuality, sodium is 22.9887, which make it closer to 23. 22.989. And that's closer to 23. We're going on to 12, which is magnesium. And magnesium has atomic number 12 and atomic mass of 24.305. 24.305. So if we double 12, we get 24. So this will be closer to the rule of doubling the atomic number. And we must remember that also that it's the number of protons plus the number of neutrons. If we say P is protons and N is neutrons, then in all cases the atomic mass will be the number of protons plus the number of neutrons and also the electrons. But the electrons has a negligible weight, and so sometimes we leave it out, but we should add it in because they do have weight. But for everyday usage, we could say it's the number of protons plus the number of neutrons. So potassium now, not potassium, 13 would be aluminum. So aluminum has atomic weight 13. We would expect the atomic mass to be about 26. But let's see. It's 26.98, which is closer to 27. So we just write 27 here because we have no space. It's 26.98. Let's write it at the bottom here. Aluminum equals number of protons plus number of neutrons equals now 26.98 is approximately equal to 27. So we on the 14, which is silicon. Silicon here, and the atomic mass of silicon is 28.06. So 14 and 14 is 28. So that one is close. So that would make it about 28.01. Silicon. 28.01. Silicon. Number of protons plus number of neutrons was 28.01. 28. So 15 would be phosphorus. And here's 15 for atomic number 15, phosphorus, and the atomic mass of 30.913, which would make it approximately 31. 31 approximation there. We could put it here now as phosphorus, number of protons plus number of neutrons equals 30.913. Approximately equal to 31. All right, so as we continue here now, we have silicon 16, sulfur 16, sulfur, and atomic mass of 32.065. 32. 17 would be chlorine, atomic mass of 35.45. So put your, it's more than double the atomic number of 17, 35. chlorine, number of protons plus number of neutrons equals now 35.45. 18 would be another rare gas or noble gas, and helium, neon, argon, 39.948. 18 and 18, 36. So this is way past the rule. So this is now 39. Which is closer to 40. So I have here argon, atomic weight of approximately 40. So actually this is 40 would be a closer atomic weight or atomic mass for argon, which is 39.948. 39.948. And the 28th one would be, the 19th one would be potassium. We have atomic mass here of 19, atomic number 19, and atomic mass of 39.018. 39.018. And 40 calcium, atomic number 20, and mass number 40.078. 40.078. So there we have the atomic mass of the first 20 of the elements on the periodic bed of chemical elements, which is just the periodic table projected on an air bed. So the first 20, and we will return with another set of atomic mass for the elements with atomic number 21 and upwards. So as we review here, note that the atomic mass is approximately double the atomic number. We could use that for a general rule, and sometimes we find that it's one mass unit over the atomic. After we double it, it's 1 over sometimes, and sometimes more than 1, as in the case of this rare gas here. Argon has 18 atomic number, but 40 atomic weight. Let's look at some of these atomic weight. We put them at the bottom. This would be 1 for hydrogen, or 1 point something, 6.94 for lithium, and so on. Beryllium would be 9.002. Sodium is 22.987. Magnesium 24.305, and so on. And we put some of them here. Aluminum, number of proton plus number of neutron, or rather number of neutron plus proton, 26.98, which is approximately equal to 27. And since we have some up here, we'll see for beryllium, for aluminum, for silicon, phosphorus, and sulfur, chlorine, and argon. And helium is up there for that. Okay.